One thing I think is very interesting is what the relationship between the algorithm and the key is. Because a lot of people don't seem to really understand that. The algorithm is just a set of a bunch of formulas, just logic formulas, mathematical formulas, and it's static, meaning you have formula 1, formula 2, formula 3, formula 4. Now what if we just use that algorithm in that sequence for each message? Formula 1, formula 2, formula 3, for every single message. If we did that, we have no randomization, and the bad guy can find patterns. Randomization is the big thing with encryption and cryptography, because the more randomized something is, the more difficult, the more work factor it takes for somebody to reverse and uncover the key and the message. So the algorithm is all of the mathematical functions, and the key is a value that tells the algorithm basically in what sequence to carry out these mathematical functions. So in a simplistic description, you have all these, let's say you have 24 mathematical functions. Well, the key could say use 3, then use 5, and then use 2, and then use 7. So the key is used as instructions for adding randomization for the algorithm, because the algorithm itself isn't going to change. And that's why we have to have the key constantly change, just like we're supposed to change our passwords. If you use the same key over and over again, then the bad guy can see patterns and start reverse engineering and figuring out what that key is, just like how people can find out what passwords are. Now, so the key is just a long string of numbers, and the algorithm is just a group of mathematical equations. In symmetric cryptography, they're going to use the substitution and transposition. That's what's used in symmetric cryptography. We'll look at asymmetric cryptography that actually uses different types of mathematics. So within cryptography, what does size have to do with anything? Why would a larger key actually provide more protection than a smaller key? Well, a lot of people have heard this. You may have heard this, that a key size of 64 doesn't provide as much protection as a key size of 128. But why? How does that provide a longer key? If those are just instructions for the algorithm, how does it actually provide more security, more protection? Well, the algorithm actually creates a key space when it needs to generate new keys. And we're talking binary here. So really, if you have a key size of 64, the key space is all the possible keys that can be created. So if you have 64 bits, that means 2 to the 64th power, and that's how large your key space is, how many potential keys that can be made. Now if you have a key size of 128, that means 2 to the 128th power, and then you're going to get a much larger key space because that's a larger number. And the key space is what the algorithm uses to make new keys. So that's the reason why a larger key size will actually provide more protection, because there's more keys, potential keys that could be created that the bad guy would have to go back through and figure out. If you had just a smaller key set and you had to guess, or you had to go through like a brute force to figure it out, that's a lot easier than if you had a whole bunch of keys that you had to brute force or try to figure out which ones used.